This question says state the transformations in the order that you would apply them required to graph the sinusoidal function shown. Describe what this does to the amplitude, period, starting point, and equation of the axis. Graph the transformed function. The first thing we want to do in order to understand how to graph this and transform it is to remember what the cosine function looks like. That's the parent function here that we're transforming. The cosine function has an amplitude of 1 and it has equation of the axis at 1 and a period of 360, and it looks like that. So what we're going to do is we're going to apply the transformations that are in the equation to that cosine function. It's also good to keep in mind what the sine function looks like. We're not going to use that here, but it is very similar to the cosine function, and it looks like what you see there. It has an amplitude of 1 as well, and a period of 360, and an equation of the axis at 0, but you'll notice that it starts at the equation of the axis and goes up from there. So let's compare this now to the transformed function. So in general, the transformed function is y equals a times cos of k x minus d plus c. So a is -4, which means it's a vertical stretch by a factor of 4. In other words, we're going to take the y values and multiply them by 4, but it's also negative. So not only are we going to multiply it by 4, we're going to multiply those y values effectively by -4. We're going to vertically stretch it by 4 and flip it over the x, the horizontal axis. The next thing to look at is the k value. And the k value here is 1/3. What that means is that we are going to do a horizontal stretch or compression. Now the tricky thing about k is it's always the reciprocal. So let's figure out what the factor is here. It's the reciprocal of 1/3, which is 3. So that means it's going to be a horizontal stretch. Horizontal stretch factor of 3. So instead of a period of 360, it's going to have a period of 1080, which we'll get to shortly. The d value is 120. It's positive because notice it's x minus d. X minus 120 up above. So that's a positive 120, which means it's going to shift positive 120 degrees to the right. And the last thing is the c value. The c value is just 1, which means it's going to shift the whole graph up by 1. So with all that in mind, let's go ahead and talk about the amplitude now. The amplitude of this function is going to be equal to 4. That's directly related to the a value. It's the magnitude of the a value. We'll deal with the negative shortly, but the amplitude is going to be 4. The period, I already alluded to, is the normal period of 360 multiplied by 3. Well, why is it multiplied by 3? Well, the period and the k value are reciprocals of one another. So effectively, you're taking the 360 degrees, you divide it by 1/3. That's the same thing as multiplying that by 3. And so that gives you a period of 1080 degrees. So there's your period and your amplitude. And so now let's look at the starting point. Because it shifted 120 degrees to the right, what that means is that it's going to start at 120 degrees, but keep in mind it's flipped over the x-axis. It would normally start at a maximum, and so because of that, it's going to start at a minimum at 120 degrees. The last thing is the equation of the axis, and that comes from the c value that shifted it 1 unit up. The normal cosine function has an equation of the axis y equals 0. This has an equation of the axis y equals 1. So we have all those properties now, and we're going to work together to graph this. Now, we could graph this using normal transformations, just like shown in front of you. But what we're going to do here is we're going to allow this to show us how to create a box that is going to fit exactly one cycle, exactly one period. So we're going to start at 120 degrees, and that period is going to end 1080 later, so it's going to end at 1200 degrees. So you can see there that my scale on my x-axis just is not going to fit. So what I'm going to do is I'm going to go ahead and change that scale to make it a little better to fit the numbers here. So I'm going to go every 3 squares is going to be 120 degrees. So it goes 360, 720, 1080, and 1440. And so I'm going to start by drawing my vertical values of the box. So my c value is is 1, so that means the equation of the axis is y equals 1. And in order to make this fit, because I'm going to go 4 above and 4 below that, I'm going up by every square being 2. So I'm going from 1 to 5 because my amplitude is 4. So that's going to be the amplitude above the equation of the axis. And then I'm going from 1 down to -3 because that's my amplitude below the equation of the axis. And so I'm just drawing those as dotted lines. And the top line is going to be the max. The bottom line is going to be the minimums. And then that middle line is the equation of the axis. So now I'm going to add the horizontal values. I know it starts at 120 degrees. It's 1/3 of the way to 360. And it's going to end at 1200 degrees. It's 120 past 1080. And so that's the beginning and the end of my cycle. And so the reason we call this the box method is what you see highlighted in front of you. That is a box. And that is going to fit exactly one period inside that box. So what we have to do with that box is we have to split it in half. We have to find the midpoint of that box, which is 60 less than 720 there. So it's going to be at 660 in that case. And then we have to split that up, and you can do that based on squares or based on degrees. What I'm doing here is I'm seeing that there's 9 squares from the beginning to end, so then 4.5 to the middle, and then 2.25 to each of the other quarter parts of this function. The key to remember is that every period has 4 quarters to it. And so if it's starting at a minimum, then it's going to go to the equation of the axis, is going to the maximum, back to the equation of the axis, and then back down to the minimum. And I can draw my curve through all those points. And what I have is I have exactly one period of that function, y equals -4 times cos of 1/3 x minus 120 plus 1. The key to keep in mind here is that I'm graphing all this in degrees. And so if you're doing this in radians, it's the same idea, but we just keep in mind that instead of 360, we have 2 pi on the x-axis. So I hope that was helpful. For more on how to graph using the box method, check out the video on the left. For lots more videos on this unit relating to sinusoidal functions, check out the playlist on the right. Thanks so much for watching.